Hi, welcome back to Moose in Chemistry. This is thermochemistry, Gibbs free energy, and enthalpy and entropy lesson 1. Okay, a couple things. Entropy is energy that is distributed or dispersed among various motions of molecules of a system. It is measured as a state of disorder, and we often symbolize it as delta S kilojoules over Kelvin. Enthalpy, which is often confused with enthalpy is heat that is evolved or absorbed in the reaction. Delta H equals sigma, which is the sum of delta H products minus the sum of delta H reactants. Its unit is in kilojoules per mole minus 1. Okay. If you get a delta H with a positive number, that means that this reaction was endothermic. In other words, it absorbs the heat. And if it's delta H is negative, then the reaction is exothermic, which means it's given off heat. Okay, now a couple things. Some formulas that we use is Q equals mass times delta H fuss, which is delta H fusion, and also Q equals mass times delta H vaporization or VAP. Gibbs free energy itself, the equation is delta G equals delta H minus T delta S. And that's one of the Gibbs formulas. There's another one out there too. And this square is really, really important. So if your entropy is positive and your enthalpy is negative, the reaction is always spontaneous. If the entropy is positive and the enthalpy is also positive, it's spontaneous at high temperatures and not spontaneous at low temperatures. These are important facts to remember. If your entropy is negative and your delta H, which is your enthalpy, is negative, it's high temperature spontaneous and low temperature spontaneous. Okay? And if your delta S and delta is negative and your delta H is positive, then it is never spontaneous. All right. Also remember that delta S positive is high disorder, which means it's not organized at all. Delta S negative is low disorder and it's organized. If delta H and delta S are known, then delta G reactions equal delta G products minus delta G reactants, which is the other Gibbs formula. All right, well, that's it for this particular lesson. You guys be snarly, and we'll see you back here at Moose in Chemistry.